Looking at the double star 6-pulse rectifier waveforms, we see that ID1 flows when V1 is the most positive, which is from that point there to that point there. So it is from here up to here. And the current that is flowing there is IL over 2. That is the magnitude. When we go to V2, the current flowing in ID2 is the current that flows while V2 is the most positive, which is from here to there with the same magnitude. And similarly, we have diode D3 current, diode D4's current, diode D5's current, and diode D6's current. And each one of them only having a magnitude of IL over 2. When we go to the primary current IA, we see that IA is the dot windings, so it is ID1 minus ID4, since the direction that the current flows into the winding here, and here it flows out of the winding. So IA will be this wave shape here, where this will be IL over 2 times the turns ratio. And on this side, it will just be negative of that same value. IB is the asterisk, so it is ID5 minus ID2, and that should give us, there's V5, ID5, and there is for ID2, and also the same, IL over 2 times the turns ratio. When we come here to IX, the line current, we see that it is IA minus IB. So all we now have to do is go and logically do that subtraction. 0 minus IL over 2 times the turns ratio is minus that value. And then here we have IL over 2 minus 0, so it will be the positive of that same value up to there. And here we have IL over 2 times the turns ratio minus IL over 2 times the turns ratio, which will give us 2 times that. And similarly, we can now go and complete the wave shape. And you will see that we have a stepped waveform. And here with IB and IA, we have quasi-square waves. And it is interesting to note that subtracting 2 quasi-square waves, 120 degrees phase shifted from each other, will give you a stepped waveform. Thank you.